The stars have always held significance for humans, but it is only recently that we have begun to comprehend vast groups of them, or galaxies, in the far reaches of the universe. The Webb telescope was anticipated by everybody as a game-changer in the field of astronomy, and we knew exactly what we believed Webb would completely astound us with. However, its most recent findings have blown away the proportions of our expectations. The Webb telescope, according to American astrophysicist Neil deGrasse Tyson, has allowed us to glimpse ghosts from the past. What startling discoveries have the telescope made that have given us an unmatched perspective of the cosmos, and how will this new image affect you? Let's find out. The James Webb Space Telescope has thrown new light on some of the most astounding findings made in the space business since it started science operations during the summer. Most recently, the Webb team penetrated Titan's murky atmosphere using the telescope's infrared vision, discovering what is believed to be a methane sea, sand dunes, and clouds. The observatory, which cost $10 billion, has also produced breathtaking photographs in incredible depth and vivid color, including some of the first galaxies that were there less than 500 million years after the Big Bang and the stellar nurseries of the Carina Nebula. The director of the Hayden Planetarium in New York, Neil deGrasse Tyson, stated that because so much had to go right, expectations were moderated in case something went wrong. He previously told Fox News Digital that it exceeded our expectations by meeting the specifications of the design. deGrasse Tyson stated, "So looking at those photographs, it is evident we are in a new astrophysics period. We have entered a gateway to a previously unattainable window on the universe." Using the Hubble telescope, the James Webb Space Telescope is a joint project between NASA, the European Space Agency, and the Canadian Space Agency, launched into orbit in December 2021. Bill Nelson, the administrator of NASA, has spoken highly of it in the past, praising its ability to look back further than 13 billion light-years. The Near-Infrared Camera, or NIRCam, of the telescope allows researchers to reveal some of the Hubble Space Telescope's most well-known discoveries. deGrasse Tyson pointed out that humans are unable to see in the ultraviolet region of the spectrum, but the Hubble Space Telescope can. According to the needs of the designers, telescopes are tuned by design to view the universe in different light bands. The eminent scientist claimed the James Webb Space Telescope translates colors for the human eye. While viewing photos taken with the telescope, deGrasse Tyson says that the brain creates an image, 3 bands of light, and assigns a color to each one before combining them to create a full-color image using RGB coding on computers. Any 3 bands, he claimed, could be used to do that wherever in the spectrum. Many of the infrared photographs show galaxies that were previously hidden by dust or clouds. Magnificent spiral galaxies can be seen in deep field images alongside pinpricks. But the question arose, are scientists looking back at some of the earliest or the oldest galaxies when studying galaxies from when the cosmos was less than 1 billion years old? The light you see from the most distant galaxies is the oldest light in the universe, the oldest light from stars in the universe. It has been traveling for 13 billion years. So in that sense, it's the oldest because it's coming from the newest galaxies. deGrasse Tyson added, "We must consider the uses of the words older and new in the context of newly formed galaxies that have been streaming light into the universe for 13 billion years. Every image from the early universe that Webb sent back has been breathtaking, according to Tyson. The telescope was purposely built to detect infrared light. According to him, there was a gap in the space-time continuum that prevented anything on Earth from receiving high-quality data from the early cosmos. This is because UV light is released during star and galaxy formation, but the light waves end up extending into longer wavelengths as they go across expanding space that has existed since the Big Bang. By the time it reaches us, it's infrared," says Tyson. Webb has observed galaxies that were formed more than 13 billion years ago so far. Additionally, it has changed how we perceive the planets in our own solar system. It's a portal through which we've been transported to a new era of high-resolution, high-quality data in modern astrophysics, says Tyson. How do you reconcile the fact that we are viewing celestial objects from such a long time ago? If it took millions or maybe billions of years for their light to reach us, are they still alive? Despite the fact that light travels at 299,792,458 meters per second, the universe is enormous. The new James Webb Telescope images may alter our understanding of the universe's beginnings. Neil deGrasse Tyson described it as the fingerprint of all the chemistry that's going on in there, adding that it also provides information about the chemical elements there and where they would fit in the expansion model of the cosmos. Recently, after the White House verified only a few data regarding the objects, rumors about the unexplained flying objects being of alien origin started to circulate. Since then, the White House has reaffirmed that there was no evidence of aliens or extraterrestrial activity, but it hasn't offered any more detail. The James Webb Space Telescope has also allowed astronomers to see back into the history of the cosmos, and they have made a surprising discovery: huge far-off galaxies that simply shouldn't be there. No one anticipated them. Astronomers are having trouble locating galaxies that are almost as large as the Milky Way and are full of adult red stars in deep field images taken by the James Webb Space Telescope during its initial observation campaign. These galaxies are so far away that to the powerful telescope they only appear as small reddish dots. They are reported in a new study based on Webb's first data release. Astronomers discovered that they were witnessing these galaxies only 500 to 700 million years after the Big Bang by examining the light radiated by them. Such ancient galaxies are not a surprise in and of themselves. In the first 400 million years of the universe's existence, when only a dense fog of hydrogen atoms pervaded space, astronomers predicted that the first star clusters would emerge soon after the universe emerged from the so-called Dark Ages. However, the stars in the Webb photos were too ancient, and the galaxies were startlingly large. The latest discoveries don't line up with earlier observations made by Webb's less potent predecessor, the Hubble Space Telescope, and they are at odds with accepted theories about how the cosmos appeared and changed in its infancy. As one of the study's authors and assistant professor of astronomy and astrophysics at Penn State, Joel Lahar, said, "We had certain expectations for the type of galaxies that live in the early universe. They are young and small. Small, blue, infant galaxies are frequently discovered in the early cosmos during Hubble and other instrument studies. These objects have just recently emerged from the primordial cosmic soup and are currently constructing their own early stars and structures. In general, the light of young stars has a bluish tint. Stars get older and redder as they use up their fuel and cool down." Webb was designed to detect distant galaxies, but astronomers were surprised to find such ancient red stars in them. Similarly, they were unprepared to detect galaxies with masses greater than 1 billion suns, but the red specks seen in Webb's deep fields appear to be 50 times more enormous than that. According to Lahar, the most massive galaxies in her sample had masses that are 2 to 4 times lower than the Milky Way's. "We're discovering galaxy candidates that are as large as our own galaxy when the universe is only 3% as old as it is now," Lahar said. Astronomers must be sure the strange red spots they are seeing are not something else before they start revising cosmology theories to explain how these galaxies formed so rapidly after the Big Bang. However, the majority of the alternate explanations also call for brand new ideas, according to Lahar. For instance, because early universe stars lacked heavy components, they might produce light in unusual ways, and possibly we're not accounting for those in our models. Alternatively, it's possible that the local star formation processes we understand, such as how many stars originate from gas concerning a star's mass, were completely irrelevant in the early universe. These discoveries would likewise be thrilling and, in a totally different way, challenge our knowledge of how stars emerged in the early cosmos. As part of the Cosmic Evolution Early Release Science (SEERS) program, Webb's Near-Infrared Camera (NIRCam) captured photos of these baffling galaxies. Soon, astronomers will point Webb's mirror back in the direction of these galaxies in order to collect spectra of their light. Spectra dissects incoming light into its component wavelengths, illuminating the chemical and physical characteristics of the light's origin. There is already pressure on scientists to update their views about the early cosmos, just a few months after the Webb team unveiled the first findings from the vast observatory. The huge galaxies are at odds with 99% of models of primordial galaxies in the universe, forcing researchers to re-evaluate their theories on galaxy formation and evolution. Meanwhile, that's not all from the James Webb Telescope. The more we discover about Stephan's quintet of dark angels, the more we realize that this part of our world is every bit as grand and terrible as it appears. Additional studies with the James Webb Space Telescope and the powerful Atacama Large Millimeter Submillimeter Array, or ALMA, astronomers announced at the annual American Astronomical Society news conference, have revealed sheer mayhem occurring among these 5 brilliant galaxies. To begin, one galaxy, NGC 731b, or the Intruder, is creating a massive shock wave the size of many Milky Ways as it invades the space between the other 4 galaxies. There's a lot of drama going on because that incredibly powerful wave has set in motion a recycling plant for clouds of warm and cold molecular hydrogen gas among the 5 of them. In a press statement, co-investigator on the experiment and astronomer at the National Radio Astronomy Observatory, Bjorn Emmons, commented, "A molecular cloud piercing through intergalactic gas and leaving havoc in its wake may be rare and not yet fully understood. However, our data indicate that we have advanced in our knowledge of the startling behavior and tumultuous life cycle of molecular gas clouds in Stephan's quintet." Even more bizarrely, the researchers discovered a huge bundle of gas by the quintet that was gradually disintegrating as a separate tail of heated gas formed nearby. To summarize the last part, this tail may be a sign of a young galaxy. Yes, that would add yet another character to the turbulent sitcom taking place at this end of the universe, which is fortunately located between 39 million and 340 million light-years away from where you are. One of the galaxies is much closer than its dancing buddies in the foreground. Shock waves, such as the one striking Stephan's quintet in the area, are typically created in front of an object moving faster than the speed of sound through a gaseous medium. The object, in this instance, is NGC 731b, which is tearing through the gaseous fabric of space at an astounding 800 km per second, or almost 500 miles per second. According to the press release, a trip from Earth to the Moon would take only 8 minutes at that pace. Using Spitzer in 2006, our team discovered a remarkable fact, said Philip Appleton, an astronomer at Caltech and co-author of a report on the discoveries. The scientists discovered an enormous amount of specific hydrogen molecules emitting in the infrared within the shock wave, combined with X-ray emissions that are generally supposed to stay pure when resulting from such events. According to Appleton, these molecules would normally not survive shock waves traveling at speeds greater than 30 to 50 km per second. Therefore, the crew naturally questioned, what's going on here? Which brings us full circle to the serious chaos we were talking about previously. As Appleton explained, the gaseous medium this shock wave is plunging into is somewhat clumpy, and these clumps seem to be shattered into tinier clumps called cloudlets as the shock propagates through space. These cloudlets are the source of the questionable hydrogen emission. The hydrogen then becomes part of the shock wave itself. To put it another way, it appears that the hydrogen in the area is recycled through both warm and cold gas surrounding the shock wave. And in 2006, when they were monitoring the wave, the crew found all that regenerated hydrogen. According to Appleton in the press release, this is significant because molecular hydrogen is the building block that may eventually form stars, so understanding its fate will tell us more about the evolution of Stephan's quintet and galaxies in general.